Before using the bearing puller to remove a bearing from a shaft, the mechanic applies penetrating oil between the shaft and the bearing. This oil makes it easier to remove the bearing. Then he sets up the bearing puller jaws behind the bearing so that they rest loosely against the shaft. Next, the mechanic hooks the side rods behind the jaws. Then he makes certain that both rods are aligned correctly on the strong back. In this example, the mechanic places the lead screw into an alignment hole in the shaft. Then he tightens the lead screw. He checks the position of the jaws to make sure that they will only push against the inner ring. A good way to check the jaw position is to tighten the puller and then turn the bearing's outer ring. If the outer race can move freely, then the jaws are positioned correctly. Next, the mechanic uses a wrench to tighten the lead screw and draw the bearing off the shaft. He is careful not to cock the bearing. If the bearing is cocked as it comes off the shaft, it will jam and the puller will have to be readjusted. The mechanic continues pulling until the bearing is loose enough to be removed by hand. After the failed bearing has been removed from a shaft, the mechanic cleans the bearing with an approved solvent to remove grease and dirt. Then, after the bearing has dried, he inspects the rings and rolling elements. He turns the bearing slowly to determine whether there is any stiffness or binding when the rolling elements turn. He also checks for signs of failure such as spalling, burn marks, cracks, dents, and pits. In this topic, we looked at some causes of rolling contact bearing failures, and we looked at specific types of failures and signs that accompany each type. We also looked at 2 ways to remove failed bearings. To test your understanding of what we've covered, try answering some practice questions. Bearings that fail must be replaced. In this part, we'll watch a mechanic prepare to install a new rolling contact bearing. The mechanic begins by carefully removing and cleaning the damaged bearing. After a bearing has been removed from a shaft, it should be handled carefully. It should not be left where it will get dirtier, and it should not be rotated, banged around, or dropped. Handling the bearing carelessly will only make the task of determining why it failed more difficult. In order to properly inspect the bearing, the mechanic must first clean it. In this example, the mechanic cleans the bearing with an approved solvent to remove grease and dirt. Then, after the bearing has dried, he examines the bearing for signs of failure. He turns the bearing slowly to determine whether there is any stiffness or binding when the rolling elements turn. He also checks for signs of failure such as spalling, burn marks, cracks, dents, and pits. If the bearing has been damaged due to misalignment failure, lubrication failure, or thrust failure, the problems that caused the failure must be corrected. In this example, the bearing has simply worn out. The mechanic then selects the correct type of replacement bearing according to the manufacturer's specifications. He checks to make sure that the part number of the bearing specified by the manufacturer is the same as the part number on the replacement bearing. In this example, the mechanic's next step is to pack the new bearing with grease. Before installing the bearing, the mechanic measures the diameter of the shaft and the diameter of the inner ring with a micrometer to make sure that all the parts will fit together correctly. When all of these preparations have been completed, the replacement bearing can be installed.